Imagine something spin. It looks like this, right? Well, now imagine an electron spin. Does it look like this? Well, not exactly. You see, particle spin doesn't look like this. It's intrinsic, which means it's like a part of a particle's genetics. Spin is also an angular velocity. This doesn't help most people's misconception that an electron is just a ball that's spinning, because an electron isn't a ball, and an electron isn't spinning. It's better to compare it to something's rotational symmetry. You and I have a rotational symmetry of 1, and this paper has a rotational symmetry of 2, if I flip it this way. If I go from here to here, or I'm moving at any speed, or I rotate it like this, we still have the same rotational symmetry as long as I don't deform either, because I can't deform a particle. There are some problems with this interpretation because most particles have a spin of a half, but that would mean it would have to be rotated 720 degrees. How does that work? So if it isn't rotational symmetry, then what is it? Well, we don't know. But if we don't know what it is, then how do we know it exists? Well, that's because of this experiment. In this experiment, neutral silver atoms were fired through this, which is basically two giant magnets. Since they're neutral, they should go straight, right? But instead of going straight, they all went to one of two extremes. This is called spin up and spin down. So there must be something causing the atoms to be deflected one of these two ways. There's nothing special about up or down. We can flip it like this and still get left and right. But what if we do spin left and spin right after we do spin up and spin down? There's still two beams. Okay, well now let's do spin up and spin down again. There's two beams again? How's this possible? We already blocked one of them. This is why it's so hard to find out what spin really looks like. We can't get a particle that definitely has spin in one diagonal. So even if spin doesn't look like this, we don't know what it looks like. Maybe you could be the one to figure out what it does.